physical equilibrium and Henry's law. So, what is physical equilibrium? Equilibrium achieved in physical process are called as physical equilibrium. So, phase transformations are there in physical process. So, three equilibria are possible in this physical process. So, the different equilibria attained are solid liquid equilibrium, liquid gas equilibrium and solid gas equilibrium. Now, first one is solid liquid equilibrium. Solid liquid equilibrium. For example, if we take ice gets converted into water. In this process, in this physical process, first the melting of ice takes place in the forward process, and in the reverse process water, that is by freezing, water gets converted into ice. Okay, so during this physical process, after some time, the rate of melting of ice will be equal to rate of freezing of water. So, after some time, the rate of melting of ice will be equal to rate of freezing of water, which means the equilibria is attained. So, these types of equilibria are known as solid liquid equilibrium. Now, second one, liquid gas equilibrium. In this process, example, if we take water, liquid gets converted into steam. Okay, that is water in gaseous state. Here, the process is taking place, and after some time, what happens? Rate of vaporization will be equal to rate of condensation. So, at equilibrium, what happens? Rate of vaporization will be equal to rate of condensation, and such physical processes are called as liquid gas equilibrium. Now, the third one, solid gas equilibrium. Example, if we are taking solid iodine, solid iodine is taken in a closed vessel. And after some time we can see that the violet vapors increases and the intensity of the violet vapors becomes constant after some time. So we can say that iodine solid is in equilibrium with iodine gas. Okay, so an equilibrium is attained. That is, at equilibrium, rate of sublimation will be equal to rate of condensation. Okay, such equilibria are known as solid gas equilibrium. Okay, so these are the three types of equilibria in physical equilibrium. So, next is dissolution of solids or gases in liquids. First, we are discussing solids in liquids. Example, if we are taking sugar solution, dissolving sugar in water. Okay, so after some time, there will not be possible to add more sugar to this. No more sugar is dissolved in the water. So this solution is called as saturated solution. Okay. So after some time, saturated solution is obtained and we can say a dynamic equilibrium is attained. So a dynamic equilibrium is attained between the solid solute, and here the solute is sugar. Sugar in solid and sugar in solution. So an equilibrium is attained between the solute molecules in solid state and in solution, and this solution is called as saturated solution. Okay, now at equilibrium, the rate of dissolution will be equal to rate of crystallization. Okay. Now, what is solubility? Solubility means amount of solute in gram dissolved in 100 gram of solvent at a particular temperature. Okay. It's called as solubility of the solute. Okay. So, second one, gas in liquids. Example, soda water. In soda water, carbon dioxide gas dissolved in water at high pressure. This is important. At high pressure only, carbon dioxide gas dissolved in water. So, after some time an equilibrium is attained. That is, an equilibrium is attained by the molecules of carbon dioxide gas, that is carbon dioxide in gaseous state, and molecules dissolved in liquid under pressure. Okay, carbon dioxide gas and carbon dioxide dissolved in the solution, and equilibrium is attained. So, carbon dioxide is dissolved in water at very high pressure. So, solubility depends upon temperature and pressure. Okay. So, at a particular temperature and at high pressure, carbon dioxide gas dissolved in the water. Okay. Now, next is Henry's law. What is Henry's law? So, mass of gas dissolved in given mass of solvent is proportional to the pressure exerted by the gas, pressure exerted by the gas at the liquid surface. Okay. So, by Henry's law, we can say that the mass of the gas dissolved in the given mass of the solvent is proportional to the pressure. So, solubility depends upon pressure at a particular temperature. Okay. So, solubility depends upon temperature and pressure. So, this mass of the gas dissolved in the given mass of the solvent at a particular temperature is proportional to the pressure exerted by the gas at the surface of the liquid. Okay. So, and we can say the equation will be M is proportional to P, or M is equal to Kp, where K is the Henry's constant. K is called as Henry's constant, and it depends upon the nature of the liquid, the nature of the solvent, that is nature of the liquid, the nature of the gas, and also depends upon the temperature. So, this mass of the gas dissolved in the given mass at a given temperature is proportional to the pressure exerted by the gas at the liquid surface. Okay, gas above the liquid surface, and solubility decreases. What happens to the temperature? Solubility decreases with increase in temperature. That is important. Okay.